Hi class, in this video I'm going to be showing you some example problems of how to find probability using two different methods. And the second method will involve your knowledge of how to multiply fractions. So here I have a question. Mackenzie spins a spinner, which is divided into 5 sections here, and also rolls a 4-sided dice once each. So here they have a sample space table for you. So they have the spinner, which have these 5 colors: blue, red, green, yellow, and purple, and a 4-sided dice with these numbers 1, 2, 3, and 4. So this sample space table just shows all the events that could happen. So for example, you could spin a spinner, land on blue, and then roll a 1. You could land on blue, roll a 2, land on blue, roll a 3, or land on blue and roll a 4. But you could also land on red when you spin the spinner and also roll a 1, etc., right? If you add up all of the possible outcomes from this sample space table, you'll notice that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19, 20 possible outcomes. The other way of finding these possible outcomes, if you use the fundamental counting principle, because there are 5 outcomes here and 4 outcomes here, if you just multiply the total outcomes for the spinner and the total outcomes for the dice, 5 times 4 is 20. You also end up getting 20 possible outcomes. So those are my total possible outcomes. Now, to answer question A, using the probability table, let's determine the probability of getting blue and rolling a 2. So in this case, the probability of spinning the spinner and landing on blue and then rolling the dice and getting a 2. Now we know the denominator is the total possible outcomes, so it's going to be out of 20. Now the top number, we just have to use our chart. Let's find where we have blue and 2 right here. So there's only one possible outcome where we spin the spinner, land on blue, and then roll the dice and get a 2. So my probability would be 1 out of 20 using the table. Now, if we were to use a different method, we would do this. So this method involves fractions. So let me ask you this. What is the probability of spinning the spinner and landing on just blue? It should be 1 out of 5, right? Because in theory, there's 5 possible outcomes, but there's only one blue. So 1 out of 5 is the probability of spinning the spinner and landing on blue. Now, what is the probability of rolling a dice and getting the number 2? Since there's 4 possible outcomes and there's only one number, which is 2, 1 out of 4 is my probability of rolling a 2 on a 4-sided dice. Now that I have the probability of each of these individually, I'm just going to multiply them together. If I multiply them together, I just multiply the top numbers together and the bottom numbers together. So in this case, 1 times 1 is 1, and 5 times 4 is going to be 20. So my probability for spinning the spinner, landing on blue, and rolling a dice and landing on 2 would be 1 out of 20, just like how I had it here. So now that gives you some options when you want to pick which to use, whether it be the table or the fraction method. Okay, now some of these work better than others. So let's say for number 2, I want to determine the probability of spinning the spinner, landing on either red or blue, and then rolling a number that is less than 4. So for this one, spinning the spinner, getting either red or blue, and then, and then rolling the dice and getting a number less than 4. So in this case here, my total possible outcomes is still 20. For red and blue, well, red and blue are up here. The numbers that are less than 4 would just be these numbers here. Blue and 1, blue and 2, blue and 3, red and 1, red and 2, and red and 3. I don't select the other colors because I only can pick red or blue. I also don't select the number 4 because I have to be less than 4. There are 6 outcomes that are either red or blue and less than 4. And I just take those 6 outcomes and divide it by my total possible outcomes, which should be 20. So my answer should be 6 over 20. Now, if I want to simplify this fraction, I can divide both the top and bottom numbers by 2. And if I do that, I'm now going to get an answer of 3 out of 10. And now that's my simplified answer and final answer to this question. Okay, now another way to solve this problem would be to use our multiplying fraction method. So think about this. What's the probability of spinning the spinner and landing on just red and blue? Since there are 2 outcomes here, red and blue, and then yellow, purple, and green are the outcomes I don't want, and there's 5 outcomes in total, technically speaking, 2 over 5 is the probability of landing on red and blue, right? Because the probability of just landing on blue is 1 over 5. So since blue and red are the same equal sections, 2 over 5 would be the probability of landing on red or blue. And now what's the probability of rolling a dice and getting a number that's not 4? Since there are 4 possible outcomes for that dice, and the numbers 1, 2, and 3 are not 4, they're less than 4, I would have 3 outcomes that would result in not 4. Now I just multiply these fractions together. And if I do that, 2 times 3 is 6, and 5 times 4 is 20. So I get 6 over 20, just like how I got it here. And if I reduce 6 over 20 by dividing both the top and bottom numbers by 2, I'm going to get 3 over 10, which is the same answer that I got here. Okay, now let's move on and solve for question 2. A coin is flipped 3 times. What is the probability that a head is flipped on the first flip? So let's say you have a tree here. Heads or tails. That's the likelihood of the first flip. After that, if I already landed on heads, I can flip again and get heads and tails again. And if I landed on tails, I can now get heads or tails again. And if I landed on heads the second time, I can get heads or tails for my third flip. Same thing, if I get heads the first time, tails the second time, I can get heads or tails on my third flip. So this ends up forming a tree diagram here. So now they're asking me what's the probability that the head is flipped on the first flip. So just what's the probability of flipping heads the first time? Well, since the first time is either heads or tails, the probability would just be 1/2 or 50%. Great. Now for B, it asks, what is the probability that a head is flipped 3 times in a row? Well, if you think about it, since I'm at 50% here for my first flip, I can either get heads or tails. If I pick heads, that's a 50% chance. Now, if I divide my 50% chance in half, because if I do the second flip now, I get heads or tails again, that's now 25% each for heads or tails on the second flip. So now if heads is 25% on the second flip, then on the third flip, I must divide the 25% by 2. So that should get me 12.5% for the third flips. And now another tip here is if you add all of these outcomes on the third branch of this tree diagram together, 12.5 times itself 8 times is actually 1, right? Or 100%. And if the second branch of the tree diagram is 25% for each chance of this happening, if you add the 25% together 4 times, you get 100% again. And then obviously 50% plus 50% is 100% as well. So that does happen. Now, if you want to solve this the fraction way, what you can do is find the probability of landing on heads the first time. That's 1/2. What's the probability of landing on heads the second time? Also 1/2, right? And what's the probability of getting heads again? Also 1/2. So now you just times these together. And we know that if I multiply these together, I just multiply the top numbers and the bottom numbers together. So now 1 times 1 times 1 is just 1, and 2 times 2 times 2 is going to be 8. So the probability that I have of flipping a coin 3 times and landing on heads 3 times exactly would be 1/8.